All right, sixth grade. So for today's science lesson, we are going with the flow of oceanic convection currents, that is. Our standards are 6.ESS 2.1, which is gather evidence to justify that oceanic convection currents are caused by the sun's transfer of heat energy and differences in salt concentration leading to global water movement. That's a mouthful. And then 6.ESS 2.2 says to diagram convection patterns that flow due to uneven heating of the earth. Now, we may not have time to do all of this today. We may have to pick up on Monday where we left off. So what do you think causes air and water to move throughout the earth? We're going to take a look at this short video. We have this tank of water, and red water and blue water has been dumped in. And as you can see, it's moving. We won't talk about just yet how it's moving. Just watch and see what you think. And then you can see that they start to mix. So in this demonstration, the blue water represents cold water. The red water represents warm water. How did the different colors move in the tank? So when they dumped the water in, the warm water, or the red water, rose to the top, went across the top, the surface, and then came back down, sank to the bottom, and started to mix with the blue. The blue started to sink immediately and went across the bottom as the red was rising to the top. So our important terms are density, convection, salinity, surface currents, deep currents, global wind, Coriolis effect, continental deflections, and the global conveyor belt. We're going to get into all of these today. What are oceanic convection currents? How does the sun affect ocean water? And how does ocean water become salty? And why does the salt content matter? So those are the three questions we're going to try to answer today. We need a little background information first. Specifically on the topic of density. Because you all have studied mass and volume, but you may have not focused much on density yet. So we want to take a look at the picture and which one would be denser, a heavy bowling ball or an air-filled beach ball? The beach ball is bigger in this picture. So does that mean it'll be more dense? What does density mean? Density refers to an object's mass per unit volume or how compact it is. So now after seeing the definition of this and you take a look, it would actually be the bowling ball would be denser. Let's take a look at what happens when you add heat into the equation. Convection. This is where we get into one of our important terms. Process of transferring heat by the movement of warmer, less dense air or liquid rising and cooler, denser air or liquid sinking. So here you can see water going through this process as it's being heated on the stove, I'm assuming is where this flame is coming from. Warm water is rising to the top while the colder water is on the outside of the pot sinking to take its place. And then eventually it will get warm and it will rise to the top. Now, we don't have a stove in the ocean, but we do have the sun, which gives us a lot of thermal energy in the form of sunlight, and the ocean water soaks it up. About 70% of the sunlight that is produced by the sun is absorbed into Earth's surface, which is the land and the ocean. And then about 30% of that actually goes back out into space. It's reflected back out into space and does not get absorbed. So if the ocean water is just constantly absorbing this sun, why does the ocean water not get too hot? Because some of you may have played in the ocean before and you can play in it comfortably. You're not getting too hot. It's actually due to the uneven heating of the Earth's surface. Okay? And so in this picture with the red, the yellow, the blue, we see it's the annual mean temperature. As you can see, in the middle, near the equator, it is very warm water. Some of that is even up to 80 degrees Fahrenheit there, looking at the annual mean temperature bar. And then as you move towards the poles, the water tends to cool. Okay? And if you'll take a look at the other image, it's because over here we have the sun. This little yellow streak here is supposed to be the sun. And as you can see, the sun's rays in part B, they are a short distance and they are concentrated on this small area. In part A, the sun's rays have to travel a longer distance to reach the Earth, and they are over a larger area. So this causes uneven heating of the Earth's surface. How does this affect the ocean? The sun provides the energy that drives convection in the ocean and produces ocean currents. And there are two main types of ocean currents that are produced. We have surface currents and we have deep currents. Surface currents are easy to remember because they're stream-like movements of water that occur at or near the surface of the ocean. Deep currents are stream-like movements of ocean water that are far below the ocean surface. So surface currents, they flow in distinct patterns around the Earth, and they're controlled by 4 factors. And the first one I want to mention is the global winds, because this surface currents are wind-driven. Global winds are winds that blow near the equator. They blow the ocean water east to west. And near the poles, they blow the water west to east. The Coriolis effect is the rotation of the Earth causes surface currents to move in a curved path, not a straight path, it's curved. So in the northern hemisphere, currents move clockwise, and then in the southern hemisphere, they move counterclockwise. Continental deflections. Earth's surface is not just covered in water. We live on a continent, okay? So when currents meet these landforms, they change directions. Water temperature. Warm water currents begin near the equator and carry warm water to other parts of the ocean. Cold water currents do the same, but they begin near the poles and carry cold water. So now the images, okay? So when we look at this image here at the top, it has all these red and blue arrows everywhere. This is our water temperature. This is supposed to help you visualize the water temperature and how it's moving. Warm water currents are moving, cold water currents are moving. On the right, we have the arrows going in a circular motion in a curved path. So that's going to help you, and it looks like a bunch of C's. So that's going to help you remember the Coriolis effect. And in the northern hemisphere, you can see that the arrows are moving in a clockwise position. In the southern hemisphere, you can see that they are moving counterclockwise. And then we have our, down here at the bottom where it says the westerlies, the northeast trades. These are actually our global winds, okay? And the westerlies is named after the way they flow. They flow from west to east. Then we have our continental deflections. You can see that you have the continents down here, and as the water hits these continents, that it starts to change direction and goes away from the continent. Now we're on to our second type, which is deep currents. Our first was surface. This is deep. Deep currents are controlled by increases in water density, which is how compact something is. And in this case, colder and saltier means denser. Salinity. Salinity is the concentration of salt in ocean water. It varies with temperature, evaporation, and precipitation, and salinity is generally low at the equator. How does ocean water become salty? This was one of our questions we're going to try to answer. We have a couple ways that ocean water becomes salty. Weathering of rocks delivers minerals, including salt, into the ocean. So when it rains, rain mixes with acid and the carbon dioxide in the air, and it forms carbonic acid. And so then that falls and can erode the rocks, and the rocks have ions in them, tiny particles, and those ions flow into rivers and streams, and then rivers and streams carry them into the ocean. And that's how the salt gets there from the weathering of rocks. And then you have the evaporation of ocean water and the formation of sea ice. These processes, though, they produce the salt, but they're counterbalanced by continuous input of fresh water from rivers and precipitation of rain and snow and the melting of the ice. So why does the salt content matter? Because more salt equals denser water. The denser water sinks, which leads to the global conveyor belt. And I'll let you take a look at this image down here. We can see cold and salty, which means more dense. Cold and salty deep currents have sank to the bottom, while our warm, shallow currents are above it. And just like in the demonstration at the beginning, It's constantly moving, and the warm air goes and travels and then gets cooler and it gets denser, and then it sinks and replaces the cool air that has traveled and became warmer and rose to the top. So now we've got a video. This is another short video. This one is about the global conveyor belt, and this just helps you visualize how the water is flowing and how it's constantly like a conveyor belt going throughout the ocean. As you can see, they have taken and colored the water at the bottom blue, and then here at the top it is red. I really like this view so you can see how it is flowing. And the colder water that's saltier is sinking to the bottom, and then it's traveling as it becomes less salty and it becomes warmer, then it rises to the top. And it is constantly in this motion, which is our global conveyor belt. So the global conveyor belt is a constantly moving system of deep ocean circulation driven by temperature and salinity. This motion is caused by the combination of thermohaline currents in the deep ocean and wind-driven currents on the surface. Thermohaline, we've not discussed that one. Thermo, if we break this down, we can see that thermo is temperature, and you can use this in a thermometer. As you know, in schools right now, they're taking temperature with a thermometer. So thermo means temperature, and haline means salinity. Okay, so we're moving on to our assignments. Now, we have seen that the convection process is the ocean water is heated by the sun, but in order to transfer that heat so that the ocean does not get too hot, convection occurs where the warm water will rise to the top, and then it will move, and then the cold water will eventually take its place as it becomes less dense and less salty. Okay. So we've got a couple assignments to help you understand this concept better. And on the top, it says the nationalgeographic.org. That is an article. I want you to read that article and find one interesting thing about the article to discuss on Monday. And then at the bottom, I came up with the title of this, Going with the Flow, and then I was able to find a game that says the same title. So we're continuing on, going with the flow here. And we are going to go to this link here at the bottom that says Space Place, and you're going to play the game. It's got some puzzles to it. I tried it myself, so don't try to not play the game. You've got to play this game, because then you're going to write down what you had to do for each puzzle in order to achieve success. Now, I have to say, I tried the first two. They were pretty easy. You at least have to do 3, because by the time I got to the third, it got a little harder. And I want you to write down what you have to do in each puzzle. Now you can play, I think there was at least 6 on the page that I was on. You can play all 6 of those if you want and write down what you had to do. But you're trying to get the little boat, it's a boat, and you're going to try to get it to move the way you need it to move by adding heat or adding salt or cooling it down or changing the current. So that's going to be a fun way for you to put to use what we've learned. And then I have an Oceanic Convection Currents worksheet that goes along with the PowerPoint presentation. It helps you remember the terms a little bit better, and I'm going to need you to complete that. So our second part of this was diagram convection patterns. And while we don't have a lot of time to discuss this today, over the weekend, I want you to take a look at this worksheet. You'll have this worksheet. You are going to color the arrows by deciding whether it would be warm or cold water based on what you learned about how temperature and salinity affect ocean currents. And then, of course, I want you to color the continents, the green, and then the ocean water blue. Make it look nice, but try to figure out, and it's okay if you mess up, because we're going to talk about it next time we're in class and see where the warmer water would be, whether you think it would be at the equator or whether it would be closer to the poles. If you paid attention to the PowerPoint, you should know the answer to that, okay? We're going to see about that. And that is it for today, guys. So don't forget to do your assignments, and then we will discuss all that on Monday.